Okay, so let's go ahead and get started because it is, I guess, past 2:45, and I think that's when I'm supposed to start. So I'm talking about Cloud Foundry. The subtitle is Inside a Private PaaS. I am not using this remote properly, but I'm Trotter Cashion. I want to let you all know this is a last-minute talk. I found out on Monday that I'd be giving it. It's still going to be totally awesome, but that's why I put the little beta tag in the top right, because that means it may have bugs, such as me looking at a slide and going, wow, who wrote that one? But don't worry, it's still going to be awesome. Usually when I give a talk, I have like a cool collared shirt, and I wear these boots because I'm kind of short, so then I stand up taller. You don't get those today. You get just me. Don't worry though, it's still going to be totally awesome. So thanks for coming. I think that you'll find some of this information useful, hopefully at least some of it. We'll see. A little bit about me first. I'm co-founder of a company called Cashion. We do consulting. We do like Rails and DevOps. And we can help you set up Cloud Foundry if you want, if you think it's cool. I go by Cashion on Twitter. So that's Homer and little Twitter birds and shit. And then I go by Trotter on GitHub. And I used to live in Philly. So for those of y'all that don't know me, I used to live here. And in my opinion, it's the only place on the East Coast I'd move back to. I now live out in California. But basically, screw you, New York. Like, you're great and all, but trust me, Philly's a better place to live. So, that all out of the way, let's talk nerdy. Let's talk about Cloud Foundry and why I think it's awesome. And let's start with what happened 2 years ago here at ETE. It may have been in this room or like the one next to it or something. I gave this talk on this thing that I thought was totally awesome. It's called Chef. It's configuration management software. There's a talk on it this morning. And it's really good. It's good for setting up servers and getting all the right software on there and making things run the way you want them to run and making it so you can repeat what you do, right? So that I need to install an app server and it needs to have Apache and PHP and whatever else on there. And I want to set it up now, and then when I need to set up a new one in like a year from now, I want it to look exactly identical. Chef lets me do that, and it's great. But I want to tell you I'm sorry, because I was talking about this shit as like, yo guys, you should get on this, like start to pick it up, you know, it's gonna be really cool. And I was like, this thing is like the greatest thing since sliced bread. Like this last picture, I basically get this great analogy of, yo, we're like the auto industry, and you know, we used to be building servers by hand, like they used to build cars by hand, and then Chef is like an assembly line. Well, Cloud Foundry is like an assembly line with robots. Like, it's so much fucking better than having like a bunch of people there going, oh, let me put this screw over here. Okay, sweet. Yep, so down the line. Like, just for I'd say like 90%, maybe 99% of your applications, you don't really need Chef. What you need is a platform as a service. And you may use Chef or something else to deploy said platform as a service, but you don't want to be thinking in terms of Chef for every single application you write. It's a pain in the butt. And in my opinion, PaaS is my new shiny. So 2 years ago, Chef was my new shiny. And I was all about Chef. Well, now this is the shiny thing I like. So bear with me as y'all get to hear about this new shiny thing. And PaaS stands for Platform as a Service. People like acronyms, so we already had infrastructure as a service and software as a service. So why not have PaaS as well? Sure. The easiest way to describe it is as Heroku. So if you know what Heroku is, it's like, you know, this great thing on the internet. Salesforce bought it for like $200 million. Heroku, you just like push your app there and whammo, it's running and it has a database and life is great. And like it's free at the first level, which is awesome. Then it gets expensive, which is not awesome. But if you want like Redis or something, you click a little button and whammo, you have Redis. Or you want Mongo, click another button, yay, now you have Mongo. Like your web scales so fast, it will make your head spin. And the thing about something like that is it lets you get to what I like to call the land of services. So there's been like this push for us to decompose our applications, right? Like you write this Rails app, and it does like everything. And you sit there and you go, oh my God, like how are we gonna scale this? It's like monolithic now, I don't know what I'm doing. And on the other side, you've got like people like Kent Beck, right? And they're going, hey, when you write a method, it should do one thing, and it should do it, you know, nice little short method, do its one thing. And then Bob Martin's all like, oh yeah, single responsibility principle, yeah, your objects, they should do one thing and do them really well. And you got Unix over here going, yo idiots, we've been doing this for like years, like each application does one little thing, you compose them with pipes and life is great. And then we got to the internet and we went, oh, that's like just stupid shit. Why would you want to have things all separate? Like, let's just make it one big thing. And the reason I think, or one of the reasons I think that happened is because running a lot of services turns out to be a real pain in the butt. Like, it's not really fun. You have to, like, each time you have to split out a piece of your application into a service, you have to think, okay, what do we need to make this thing run? Well, we need MySQL. Okay, so I guess we need a chef recipe to make sure MySQL's set up correctly. All right, cool. Well, it needs to have a patching from it, so yep, we need to make sure we have the chef recipe in for that. And okay, sure, we need to get a box. So somebody go talk to Ops, tell them we want a box. And Ops is like, oh, well, you know, we decided we didn't want to use EC2, so it's going to be like a month. And you're like, seriously, dudes? Like, all I want to do is spin up one new service. And this is ridiculous. Fine, I'll just like shove this thing in as another controller in my Rails app or, you know, another class in my Spring application or whatever the hell you're doing, right? You're just shoving all these things in. And that's not the best way to do things. We should have our applications do single things and do them well in the same way that we have every single other piece of our code do single things and do them well. And Cloud Foundry is something I think that lets you get to this land of services a little bit easier because it takes away that feeling of, well, I don't know where the hell I'm going to put this thing once I write it, so why write it in the first place? The other place I see Cloud Foundry being really interesting is in this idea of empowering employees. So let's talk about like a big enterprise company, right? You got this ye old big enterprise company, and it's like humming along, or like more enterprise, and it's like falling over and over down a hill, and it just has a lot of momentum, so it keeps on going. But you have a lot of people inside that organization who know how to program, right? Like, look at a company like, say, Comcast, right? Comcast is a big-ass company, and they've got a lot of developers in there. And those developers are in there, and they're like having to do stupid shit, right? Like, some manager somewhere goes, hey, you know what would be awesome is if we have all our developers send us an email like every 2 days that lets us know what they've been working on. And they should put all their commit messages in there so that we can like review that and know what's been happening. Like, this is the kind of thing I've seen happen places. And it's really stupid because you can just go look in Git and see the commit messages. But whatever, they want an email for it. And so some developer goes, hey, I'm smart and I'm not going to do this myself all the time. I'll write a little application. And it's going to send this email for me. So I set it up on like a little cron job or something, and like every 2 days, boom, it runs, sends out my email, life is great. And then Tom looks over, he goes, man, how do you keep writing all those emails? And Bob's all like, well, I wrote an application for it, sucks for you. I would give it to you, but I don't really know where to put it. Like, I guess you can like, I'll email it to you and you can run it yourself. And so now Bob and Tom may have it, but like you've got 1,500 other developers who are sitting there going, God dang it, okay, fine, I'll like copy and paste all this shit in and set up my email. Well, with something like Cloud Foundry or some other platform as a service, it doesn't have to be Cloud Foundry, right? Like just a platform as a service in general. If you have that, then the guy can write a little app, throw it up there, and then people just come and they go, yo, I'm like Tom at Comcast.net, and hits the button, and all of a sudden he has his emails getting generated every 2 days or whatever. So it gives this way to empower your employees to get around the stupid shit that you might put in their way and then share it with everybody else in the company so that everybody else gets that benefit. And it doesn't just have to be like something stupid, right? It could be that like there is some like special thing they want to do to just help out the company so you can like count your revenue better or whatever, like sit there with your piles of money and be happy about it. Like they have a place to deploy that so then their boss can go, sweet, we have like tons of money now, life is grand. You get that sort of thing as well. It gives these people a place to put that. They don't have to go, well, I made this thing, but I'm not going to go bother with ops to deploy it internally, right? Like, it's just a stupid app. Who cares? I'm not going to go through the trouble. If you give them a platform as a service, there's a place they can put it, and they don't have to go through trouble to do it, so they might as well just do it, and it makes it easier. So a lot of this sort of thing, right, in my mind comes back to another shiny toy of mine that I've liked in the past, which is Erlang and OTP. Erlang and OTP in many ways like solved this issue of having a bunch of services running and like handling the orchestration of that shit. So within Erlang land, what you do is you set up like each application as like an application. So you have these independent applications within a given Erlang VM, and they have ways to talk to each other. And then there's a monitor up top that's like, okay, when we start what is this entire system, we need to have like 2 chat servers and 2 web servers and 1 like service registry running, and just spins those up and runs them. And then you can do like a code upgrade and it'll upgrade things, and Erlang OTP is great and yay. But they solved it in this like Erlang specific way, right? It all runs on the Erlang VM. What you want is something more like a platform as a service where it's language agnostic, right? So you want something like Heroku, where Heroku has this idea of build packs, where they're like, if you just tell us how to run your language and your application and how to build it, then we'll do it for you. You just tell us what needs to be done. And so that's where you want like this extra step of a platform as a service type thing. So my feeling on how to understand something best is to try and build it. Like when I was a kid in like all my math classes and stuff, you know how we all had like those TI calculators? And the teacher would be like, okay, we're gonna do like geometry now, or we're gonna do like calculus, and you need to be taking integrals and blah, 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 blah. Well, the easiest way for me to understand that was to write a program on the calculator that did it, and then when I had the test, instead of having to remember how to do it, I just run my program and it would work. So we're gonna do something similar here, right? We're gonna think about how would we, if our boss were to come to us tomorrow and be like, hey, you know, I went to this great talk by Trotter, and he was telling me we need a platform as a service, but I don't know about the Cloud Foundry thing. Let's build our own. Like, this sounds like a great plan. What I want to do is examine what would we maybe do if that was what our boss said to us. Well, we might quit, yes. We might be like, you're a fucking idiot, dude. Someone else already did that. Like, why would we do it too? But let's pretend for a minute that you really like to build shit and you're not going to quit. So, oh, and by the way, I happen to like, you know, maybe drop the occasional F-bomb or curse here and there. Sorry, it just happens. That's like the way I talk, so it is what it is. So the first thing you might do when your boss comes to you and goes, hey, we need a platform as a service, you go, okay, well, I guess what I'm gonna want is some application that I can talk to and tell it, yo, I want an app. I'd like to have an app running right now. That'd be really cool. And at some point you're gonna want to tell it, hey, update my app, right? Like let's update things. You may want to tell it to start, stop, and restart that app. And you're probably gonna want to say like, hey, map this application to a URL. Let's say for a moment that our entire application runs under a domain such as like vcap.me, you know, hypothetically. And then when you deploy an app, you deploy it to say like trotter.vcap.me, okay? So then anybody that goes to trotter.vcap.me gets to see it, and that's where our mapping URL bit comes in. So you might write a little Rails app that you could send these commands to using, say, some command line client. We'll call it like VMC or something. And that's what the cloud controller would do, okay? The cloud controller is just going to sit there and take those commands and be like, sure thing, boss. I like that. I like that you want to send an application up right now. This will be a lot of fun. Unfortunately, if you really want to develop things well, you probably don't want the cloud controller to actually be the one responsible for starting the app. So if we just start there, we just have a guy going, yep, sounds great, but he's not actually doing anything. So the next thing we'll probably do is, because we're dealing with clouds, we're going to call it a droplet, like a little raindrop, because we're cute. And we're going to make this droplet execution agent. And so when you tell the cloud controller, I want to push an application, the cloud controller is going to go, yo, DEA, Trotter wants to push an application. You got space? The DEA will go, yeah, I got space. Let's run one. And then the cloud controller goes, okay, well, here's the code. And the DEA goes, oh, okay, cool. Yeah, thanks. I'll run this code for you. And it spins out the code and it runs it. And it's going to assign it a port, because you can't give it 80, because if you're running a lot of things, they can't all have 80. So it's going to give it some random port, and it's going to manage the resources. It'll say like, okay, this application gets 2 gigs of RAM. If it goes over 2 gigs of RAM, we're going to kill it, right? Or if it uses too much processor, we're going to kill it. Or if it tries to access the wrong disk space, we're going to kill it. Or whatever else. You could, you know, put it inside a jail so it just doesn't know about disk space that you don't want it to access. And then the DEA is also going to be responsible for knowing about runtimes and frameworks. So it's going to have that conception of, you know, okay, I know that Ruby exists, I know that Java exists, I know that Rails exists, and I know that if this dude's trying to spin up a Rails app, then we need to write out a database YAML so that he can connect to the right database. So that's all the DEA does. And that's That's great and all, but if we're building a good distributed system, we don't want to have to hard code stuff in the cloud controller that tells it where the DEA is, or stuff in the DEA that tells it where the cloud controller is. Because that's going to be really annoying, right? Like, let's say that the DEA dies one day. Well, now what do? Right? We need to go redeploy our cloud controller because we put the DEA on a new box. That's kind of dumb. So we're going to introduce a message queue in between, okay? And we'll call this message queue nats. And what this message queue is going to do is cloud controller is going to shove messages in there. So instead of directly telling the DEA, it's going to tell the message queue, it's going to go, hey, I want an application. If there's anybody out there who would like to respond to this request for an application, please get back to me over here. And the DEA is going to go, I like those kinds of messages. I love running applications. Let me go get that. And it's going to respond back and say, hey, I'm running your app. And because we're running a really good distributed system, everything's going to be idempotent, right? So that like if things fail, we can just send it again. So the cloud controller is going to be on like some sort of timer, right? And it'll be like, after 60 seconds, if no one has responded to my request, I'll just send it again. You know, we'll see what happens. Someone else will spin one up maybe. We'll see what happens. And so that way, if your DEA happens to be down, right, like let's say it was dead because someone like tripped over a power cable, like I will probably do in a minute, and they destroy the whole thing, no big deal. When it comes up later, it'll get a message off nats that the cloud controller will have sent again, and it'll be running the application. And if for some reason the cloud controller sent it like 5 times and you know it was just like some weird network connectivity issue, well, then the DEA is running the app 5 times, but we'll deal with that in a minute, right? Like, no harm, no foul. Oops, we have 5 apps instead of 1. Probably okay for a few minutes. So now we have an issue where we have apps running. We have a way to tell our cloud controller that, hey, I want an app. And it has a way to talk to the DEA to say, hey, set the app up. But we don't actually have a way to access that app. We've bound it to some random port, like, you know, 33791. And we want to make that map to trotter.vcap.me so that we can actually, you know, go hit our app in a browser. And that's where a router comes in. So what this router is going to do is it's also listening on nats. Okay, and so when the DEA finishes setting up an application and starting it, it's going to go and send out a message going, hey, guess what, guys? I've got an application. It's running at 33791, and it wants to be at trotter.vcap.me. I really hope someone out there would like to send requests to me. It's going to be great. And the router goes, hey, okay, I like to do that. Let me take that off. Let me send that thing some messages when people come to trotter.vcap.me. And that's all it does. Okay? You send your request. It's going to go through the router, and it's going to send it to the right place. So it knows about host names, IP addresses, and ports. The reason it needs to know about IP addresses is because the DEA could be living on a different box than the router, right? We're building a nice distributed system. We have a message queue in the middle. Everything doesn't necessarily have to be on the same box. So the DEA, when it sends out that message going, hey, I'm running such and such over here, it's going to say, I'm running such and such on 10.10.10.20 at port 33791, and then the router knows to send all requests over there. And then the router itself is what gets to bind to port 80, and it communicates with the DEA and the cloud controller potentially only over nats. All right, that's the only way it communicates with things, is over nats. And the reason it might need to communicate with the cloud controller is because the cloud controller is going to say, let's say we send in a request to map a URL. Like maybe my application is so cool that I want to run it on 2 URLs because I'm just bad A like that. I want it on trotter.vcap.me and bob.vcap.me. I can tell the cloud controller, yo, give it another URL, and it'll do that. And then that'll send out an event going, hey, we're mapping a URL, and the router will pick that up. So this is all well and good. I'm going to let y'all ponder this while I take a sip of water. But what about that case we mentioned a while ago where, hey, we thought the DEA was down, but it wasn't really. So we sent out like five start messages, and now we have 5 applications running. Well, we want something called a health manager. And what the health manager is going to do is it's going to sit there, right? And it's listening to all the events coming in over nats. It's just like hanging out going, hey, what's happening now, guys? Oh, it sounds like a cool party. And then it's also looking at the database. So this cloud controller is going to have a database of what the state of the world should be, right? We should have 1 application instance, not 5. And it's going to go, wait a minute, there seems to be 5 application instances right now. This doesn't seem appropriate. And so it's going to kill them. It'll kill 4 of them. to bring the state of the world back to where it should be. So if maybe we were supposed to have 5 and we had 0, it can bring the state up to 5. And what happens then is instead of these things needing to worry about continually checking in and going, hey, do I need to be 5 right now? Do I need to be 5? Do I need to be 5? The health manager just sits there and handles that. And it thinks about that and it sends out messages saying, hey, we need 5 of these now. Let's spin some up. And the beauty of something like this is, let's say that you're running you're running 6 application instances, okay? And you have 2 DEA boxes. So 3 of your application instances are on one box and 3 are on another box. Well, what if one of those boxes dies? Just done, Like hard drive fails, you're not bringing that thing back up, you're screwed. No big deal. It dies. The health manager is going to notice, hey, we seem to only have 3 now. We need to have 6. And it'll tell that other DEA box, bring up 3 more if you can. And then you get back up to a good state. And so this provides for nice migration mechanics as well, because you can kill a DEA, spin up a new one, and your apps just kind of make their way on over. No big deal. And so what I've just described is basically Cloud Foundry, right? NATS is the message bus that it uses. It's like a hand-rolled thing by this guy, Derek Collison, who's crazy smart. The command line client they use is VMC. Cloud controller is the name of their cloud controller, and they did call it a DEA as a droplet execution agent. The thing is, though, what I showed you was it's a simplified version. They've as they've been working over the past year, it was released a year ago. They have started to pull things apart. So the cloud controller used to be responsible for user authentication and management. Now they have a separate application that does that. And I forget which it was, either DEA or the cloud controller was responsible for staging an application. So saying okay, let's put all the pieces together, let's make sure we have all the right gems for a Ruby app, and then let's bundle it up into one little tar that we can send off places. They now have a separate staging application. And I expect to see that continue, right? Things will continue to filter out into smaller and smaller services. But ultimately, it comes down to an idea like this, right? The high-level idea is still something like this. Some key facts about Cloud Foundry is it is from VMware. It is fully open source. And it was open sourced a year ago today, which is interesting because had I given this talk to you yesterday, I would have had this nice little gripe for you where I would have complained about the fact that all their development is done behind a wall, and then a month later they throw it over a wall and then you get the code. Well, as of today at noon, 2 hours ago, they fixed all that and life is great now. They now do all their development in the open. So when you commit, it goes into their public, their Garrett instance, so they can do code review and run it against Jenkins, and then it goes into the public Git repo. So they've completely fixed that problem, and it's really nice to see that because it makes it a lot easier to keep up with what's going on and contribute back. If you want to find out about Cloud Foundry, the open source style, you go to cloudfoundry.org. That's where you get access to the open source code. That's where they'll show you how to get to their GitHub instance, and they'll show you how to sign up for their Garrett code review stuff. And if you wanted to play with a publicly hosted version of Cloud Foundry, you can go to cloudfoundry.com, where they run their own publicly hosted version. You're not required to use that. And Cloud Foundry is, at least in the private sense, the open source sense, completely free. You don't have to pay VMware to use it. You just go download the code off GitHub, and then you run it, and sweet, life's good. So, is it production ready, right? Is this something that you can go, okay, well, I used to use Capistrano to deploy my applications, or I used to use Chef to write recipes and deploy them. Can I just replace the whole thing with Cloud Foundry? My answer is probably. I haven't done it. So, I'm not sure. They're running cloudfoundry.com really well, and it runs a lot of apps. So the odds of it being able to run just fine are pretty high. But I cannot tell you without a doubt that nothing will screw up. It should be just fine, though. If you're going to use it for that internal case, right, where I was talking about empowering your developers to do stuff, to make internal apps that help, I would say is 100% ready for that. Just go for it. Just run it and be happy. So if you want to try it out without having to do any work, they had this concept of a microcloud. And what it is a VM that you download and run. So if you're on a Mac, you're going to have to get VMware Fusion, which I strongly recommend you do anyway. Oh my God, if you use VirtualBox, you should just shoot yourself in the face. It hurts. Oh my God, it hurts. So spend the 80 or $100 or whatever it is for Fusion and just love your life. So much better. I went through like 4 days of trying to run chef scripts against a Vagrant VirtualBox, and it like locked my box every single day. It was awesome. So you just download that VM, run it, and you're good to go. So along those notes, let's switch over to that micro Cloud Foundry that I have running, and we can play with it, and I can show you how this stuff actually works. Let's make sure that, okay, cool. Everything's pretty visible. We'll keep it like around here. I'm not sure I can actually increase the font size of this, so sorry, but my terminal will increase. This is just like a bunch of stuff you can do to the micro instance, like, you know, tell it what services you want to have running and stuff. But the easiest way to interact with all of this is to shrink this to something that you'll be able to see perfectly, and then make everything really big, which then undoes my shrinking. And then, so can y'all see the stuff? Nope, you can't. It bleeds off. Okay. There we go. Okay. So what we do is we use a command line client I was talking a little bit about, VMC. And the thing behind VMC is it can target multiple clouds, right? So right now, we happen to be targeting my local instance, okay, my local micro cloud. If I wanted to, though, I could just as easily target cloudfoundry.com, right? And now I'm targeting a publicly hosted Cloud Foundry instance, and I could deploy my app there. But we're going to start back here. Oh, and by the way, normally if I like strongly prepare a talk, I don't do any live demos, so hopefully everything works here. We'll see. The first thing we can do is see if we have any apps running. The answer is yes. It's this Caldecott app, which I'll talk about in just a minute. But let's not worry about that one for now. Let's instead push what I'm in right here, which is this Sinatra Play app. And the Sinatra Play app is this. It's a little hard to read, but basically it's a Sinatra app that knows about a potential Redis instance and just returns a little information telling you like what environment variables it knows about and saying hello. So back over to our deployment. It asks us, here actually, let's do this too, since y'all may be seeing like the backs of some people's heads. There we go. It asks us, would you like to deploy from the current directory? And I'm all like, yeah, I do. And then it asks for a name. So we'll call this one Philly ETE, because we're at, actually we'll call it ETE, so I don't have to type as much, because we're at ETE. And it's like, do you want to deploy it to ete.trotter.cloudfoundry.me? Remember I was talking earlier about using subdomains to map things? This is how we do it. And then it goes, hey, I think this is a Sinatra app. And I'm like, you are correct. You're so smart. And it says, you probably need 128 megs of RAM. I'm like, you know what, you're probably right. And now it asks us, how many instances do we want? So right now we'll just say one. Okay, we'll keep it simple. We'll just run one instance. This would be akin to starting up with Heroku and just getting the free account, right? Yeah, one running instance. Do we want to make any services to bind to? For now, you know what, we'll say yes. And we'll give it Redis, because we know that this app knows about Redis. And then we'll specify the name of this one as Redis ETE, so we can play with it a little bit more easily in a minute. So Redis ETE, nope, we don't need any other services. And we won't save the configuration. If you save the configuration, then you can take that config, and then when you deploy it somewhere else, it'll just use the exact same config. It won't ask you all those questions again, right? It'll just be like, oh, you need this. And you could like check that in to Git to keep record of, you know, on this day, we were running one instance, and it was a Sinatra app, and it had Redis, and yada, yada, yada. So, starts the application, we're done. We have already deployed our app. I was like talking for way too long to show you how fast that was. We'll make this smaller, or actually we'll make things bigger, and then smaller. Yeah. And then, what do we call it? ete.trotter.cloudfoundry.me. And it dies, because I don't know how to write an app or do a demo. But we'll deal with that in 1 second. Most likely it has something to do with some errors. So we'll say logs of ETE, and we want all of them. And then you'll get to see the magic of screen and a backtrace. We see that if my text was not so big, I would know what happened earlier. Oh, I'm trying to do something stupid. You can't run keys. Or it's just mad at me. So what we'll do is take this bit out, and we will update ETE, so it knows which one, and it'll stop it, and then it'll start it up again, and there we go. I hate you so much right now, computer. That should have been it. Oh. It's probably mad about that. We won't go looking at logs again. Those were really big. It's much easier to just type shit in and see what happens. Yep, that was it. Success. So what we see here is it saying, welcome to Cloud Foundry. I'm running on 127.0.0.1 and port 47.980, right? And my Redis is over here, and the value of foo would be blah, but we don't get that because Trotter screwed up his demo. And then here's all the environment variable info, right? So they shove a lot of stuff into just like top level environment variables to make life easy. Like here we know, hey, we're running at that app host, and this is the name of our app, and this is some instance information, and where's Redis in here? Redis is around here somewhere down at the bottom. Here's your Redis instance, but you can also look at things like this, like vcap services, which is a JSON blob. And so let's say we had more than one Redis. You could figure out like which Redis you want to talk to there. You could like look at the name and go, oh, you know, for some things we put in the Philly ETE Redis, and some we put in the other Redis. But you'll notice we don't have that like one port, right? What if like we got really popular, right? And it turned out that everybody wanted to come use this ETE app because they were like, well, that's so cool. You can see like port numbers and stuff. And we want to give it 3 more instances. So we do VMC instances plus 3, done. And now we're running 3 different instances, as you can tell by these like port numbers changing, right? It's like really easy and fast to do that. It's not like I'm sitting there going, okay, all right, now what am I going to do to add more instances? Okay, well, I guess we need to change in Chef Server that we have these other boxes now. So we need to make some new node configs and yada, yada, yada. Like, no, you just say plus 3 and you're done. And then later on, you're less popular because it's nighttime and everybody went to bed, and you do minus 3, and then it goes back down to 1, and then like life is good again, right? And because the pluses and minuses may be weird, right, you could just say 6, and it'll try and take you up to 6, all right? So that's like nice and simple-ish, right? But, you know, we had that issue with Redis, and we're like, maybe we want to see like what's going on in our Redis database. Well, they provide this service called Caldecott, which is what that other app was that was running. And so actually, let's have a look at our services. So we have this service Redis ETE, and these are the various services they support out of the box. So there's MongoDB, Postgres, Rabbit, Redis. There's a MySQL service that if you're not using the microcloud, it's pretty easy to add in. And so here, though, we know about our one Redis ETE one, and so let's say that, oops, let's say we want to tunnel to Redis-ETE. It's going to set that up, it'll bind it. It's like, oh, do you want to run a Redis client? I'm like, I sure do. And now I just have a Redis client, and I can be like, what keys do we have? Don't have any. I could set food. This is cool. And then I can get food, right? And so all that stuff, like I'm interacting with the actual Redis instance. So had I not borked my Sinatra code, you'd be able to see that, but sorry, I did. So we can get out of there. As far as like different runtimes they support, out of the box, you've got Java, Ruby 1.8, Ruby 1.9, Node, Node 6. There's also Erlang support, Python support, PHP, .NET, like a gajillion others. It's like it's not that hard to add another runtime. So if you're like, oh man, I only like to code in like Scala version 3.71, like fine, you can do that. Okay, no big deal. And then as far as frameworks go, for when it was all fancy, it was like, oh, I think you're running Sinatra, and I was like, yeah, I am. These are the frameworks they've got out of the box. We got Spring, Java, just like a normal Java app, Sinatra, Grails, Node, Lyft, Rails 3. I know there's Django and other things. Yes?
Why does it need to know about frameworks?
It doesn't necessarily need to know. I think that a bit of it is they put those in there to make it easier for, like, let's say you're deploying a Rails app. One thing they can do by knowing that you're deploying a Rails app, they can go ahead and set up your database.yaml for you. So instead of needing to know about the environment variables and stuff and figure that out yourself and then plug it in, they can just kind of like shove in a database.yaml. They also, if you want them to, you do not have to have it do this, but like let's say you're running a Sinatra app and you want to just say, yo, Redis connect. You don't necessarily have to parse out the host name and port of Redis. They will inject some shit into your code to, when you say Redis new, instead of connecting to localhost, they'll connect to your actual Redis instance. So injecting shit into my code sometimes scares me, but you can turn that off for when you don't want that to happen. So those are the runtimes. There's a few other like little things you can do with their tool, but that's that. But let's say that like so I've been developing this locally on my micro cloud, and life is great, and I'm like, woohoo, yay, I can run it on my micro cloud. And my boss is like, hey, can I see that app you've been running? And I'm like, oh, yeah, about that. That's running on my box. We should probably put that somewhere else, so you can see it. So I'm going to go over here, and I'll target the big boy Cloud Foundry. So now we're targeted there, and we'll say, you know what? Push this up there. I'll say, yep, deploy it from here. We'll call it Philly ETE this time. Looks like a great place. Yep. No, it's not your app, but whatever. Close enough. We won't bind any services this time, and we won't save the configuration. So we push that up, and then this will finish in 1 sec. And now we're running on cloudfoundry.com, right? Like this is on the internet. You could go there on your phone and like it would hit it right now and you'd see that. And the beauty of having something like this is that, right, if you're using like, let's say you're using Heroku, right? So you're using Heroku and one day AWS goes out, which occasionally happens, not often, but occasionally. And you find out that your Heroku app was running on the zone that went down. You're just kind of shit out of luck. Your app's dead. And you are now off the internet. Congratulations. Hope you have fun for the next 8 hours. Well, if you're using something like Cloud Foundry, your data may not be there when you need to switch to a new cloud, but your app can be. You can get back up and running. If you're doing good data backups, you may be up and running with like, say, last night's data. Good enough, right? Like close, at least you're running instead of sitting there going, oh, well, yep, shit, nothing's happening now. So you can just target a brand new cloud, right? Like let's say you were using, there's a few partners out there right now. There's like AppFog, and there's PaaS.io, and there's Iron Foundry, and then there's cloudfoundry.com. So let's say cloudfoundry.com goes down. Fuck it. I'll go to AppFog. We'll use AppFog for a little bit. When it comes back up, I'll go back to Cloud Foundry. Life is good, right? You can easily migrate your stuff. Or if, let's say that like one business decides to start charging you a boatload of money one day, screw them. We'll go over here instead. And that's pretty possible. Like the various providers do have like slight tweaks. They may have like a difference here. They're like maybe one supports .NET and another one doesn't, right? But for the most part, it's a pretty common platform. You can migrate. It's not that big of a deal. So I think that's most of what I wanted to tell y'all about. One other thing. So remember I mentioned this whole like, at noon today, they decided they would do a big announcement that Trotter could watch while he was taking a shower. So much fun. Trying to figure out what he needs to add to his talk. They today released this really cool tool that I want to look at more called Bosch. It is basically this like totally badass way to manage your infrastructure stuffs. So let's say you want to deploy Cloud Foundry, right? And you're like, oh, this thing was so cool. Because by the way, up until a few days ago, deploying to Cloud Foundry, fantastic. Life is amazing. Like, you got your app, boom, it's up here. Oh, I want it on this other cloud, it's over there. But deploying Cloud Foundry itself, kind of a pain in the butt. Like, it was not easy at all. So they had like this one part and it was working great. And then the other part, not so cool. But what they weren't telling you is they had this really sweet tool internally they were testing called Bosch that they open sourced today. And so that's fully available as well. So you go to Cloud Foundry or github.com/cloudfoundry/Bosch, BOSH. You can download that code, and that will deploy Cloud Foundry like a champ. And in addition, it will deploy damn near any other service you've got like a champ. Okay? So this is something I want to play with more. I need to figure out more about it. Literally, I have like skimmed the docs right now, and that's about it. But it looks like a really cool, at this point I'll call it like a really cool alternative to using, say, Chef Server or something. What it can do is it integrates with, right now they have it working with vSphere, and they mostly have it working with AWS. So you can say things like, hey, I need another MySQL instance. And it knows how to go to AWS, turn on a VM, select the right AMI, install MySQL on it, and attach it to all your stuff. And so that's pretty sweet. And that's really sweet in terms of like Cloud Foundry, because like with Cloud Foundry, if you spin up another DEA instance, since everything communicates over NATs, you don't have to like change all your other stuff. Like you just spin up one DEA, and it goes onto NATs and goes, yo, I'm a DEA, I'm here, send me stuff. And everything just magically knows to send it there. So you can use this tool to go, hey, we need new DEAs, we need 5 of them. And it has a command line client very similar to the VMC tool I was just showing you, and you're like, I need 5 more, and 5 more come up. And so that's really cool stuff, and it's something that I think is an exciting new development and will be fun to play with. So that is all I've got. I've got plenty of time for questions if you'd like to ask them, or like if you want to just come punch me in the gut, I guess we have time for that too. But if you're embarrassed to ask a question or don't know what to ask but just want to talk to me, feel free to like find me after this as well. Yes?
So why would the controller keep a Chrome messages.nav if there's a health manager?
It wouldn't necessarily. You could just have it not. And I'm not sure the specifics of their internals. They may send it once or twice. They may not send it at all. But the health manager does a world health check like every 5 minutes. So it may take a little while for the health manager to pick up on it, whereas like the cloud controller at a given moment can know, hey, I need one of these now. I'm supposed to be getting one now. But yeah. Anything else? Yes?
So what are some other things like Cloud Foundry?
So other things like it. You have Heroku. You have, what is it? Okay, so there's one coming out of Red Hat in May. OpenShift, I think, is the name of it. And there's some other stuff too. I forget what though. I have not seen any. Oh, there's Ubuntu has what's it called, Juju or some shit like that. Something weird. It's like kind of similar. I haven't seen anything as well fleshed out as what Cloud Foundry has done. Like VMware has thrown a large team at this thing. They have a lot of people working on this, and they're open sourcing all of it. So it's kind of nice. Like I really appreciate that. And I really think that if you're a large company wondering how you can like help your developers internally deploy apps to like help themselves out and help out the rest of the company, I think you would be a fool to not look at Cloud Foundry. I think that it's just so easy for your developers to use, and it's not too terrible to actually get set up that you're just foolish for not trying it out. Anything else? Yes?
Pricing versus like Heroku.
So if you were to host it yourself, it's whatever you're paying your hosting company. So let's say you were to need a DEA box, a cloud controller box, like 1 or 2 services box, and you're running on MySQL, you may be paying, running on EC2, you may be paying, you would start, at the beginning you can run it on like a single EC2 instance and be paying like, what is it, like 70 a month or something like that. And then as you scale, just as you need to add more nodes, you'll just pay that. You don't actually have to pay VMware anything. If you wanted to run it on cloudfoundry.com, which is their public version of it, that is currently free. They haven't announced any sort of pricing on that yet. That is subject to change though. They may announce pricing at some point. And I'm pretty sure right now you have a limit of using up to like 2 gigs of RAM or something. Anything else? Yes? Okay, so in relation to say like OpenStack or CloudStack or Eucalyptus or something like that, this sits like 1 level up. So I consider OpenStack, CloudStack, Eucalyptus, EC2, right? Those are all like the same level. And the same way you could run this on top of EC2, you could run it on top of OpenStack. Cool, all right, thank you.